properties of waves in the air. Take some time to read through this. I'm going to go over it again. These are important. Transverse waves, these terms are important. We'll do it on the handout. We were just talking about waves approaching a barrier, whether it's straight on, with 0 degrees angle of incidence, that's straight on here. They come straight back a second later. Then we're talking about oblique angles, angles that are not 0, not straight on. They reflect at the exact same angle. We just went through the terminology. Now, I'm going to pause the video because we're going to actually take a look at some of these waves on the apparatus. So, on the video, you didn't see this, but we just took a look at waves on the wave machine. Now, what happens if you have a round wave in a flat there? Let's take a look at that, and then flat waves, straight waves coming into a circular, or actually a parabolic. Well, apparently, when linear waves strike a parabolic surface, parabola, x squared, that kind of shape, the waves reflect to the forward. I'm going to pause this and we're going to just demonstrate. Okay? You can Google this stuff up if you're watching on. So we just observed straight waves coming in, linear waves coming in. And this is what you kind of see, just explain it through this. Okay? You can jot that down. You don't have to have as many circles. It's sort of what I did with other things, right? But have it coming to a point, okay? Reflected waves, right? Linear waves come in from a parabolic curved surface, sort of semicircular kind of parabolic. They come to a focal point. Now this is important. As you're jotting this down and you're asking that science center. Have you ever played around? It's like a little mini satellite dish where you whisper in one end and someone's across the playground and they can hear you whisper, right? That works the same way. That, not too many people have these now, really streaming. But those little mini satellite dishes for Bell Express, TV, you guys know what I'm talking about? That's the curve that they're using. And it takes a lot of signal. Now you couldn't just have a receiver here in the middle. It's placed at that spot on the curve. These waves come in. They all bounce back to the receiver. So you get a lot of signal collected onto one spot, and that's where you're using that. Old school 1980s satellite dishes. Maybe if you have people on farms, like tend not to get rid of junk because you've got a lot of space. Have you ever seen one of those old school satellite dishes that are 12 feet across or whatever? I know there's one in my neighborhood. Must be 40 years old. But the technology at that time, the receivers weren't as good, so they had to have huge dishes. Right? I don't know what the hell it is. It's probably about 12 feet or 3. I don't know. But anyway, pretty big to collect enough signal to get in here. Now those Bell Express do one. I don't know. You guys know them. That's the way they work. That's the way. Where you come back up and grab yourself. So on the video, we just observed this on the wave table, but curved waves that hit a flat, straight barrier will return the opposite direction as a curved wave that spreads out forever. If you're watching from home, this is the kind of stuff we demonstrated here on this. So first of all, this one. There we go. So straight pulse. You see it come back? It's hard to a little bit on here. It's the same kind of wave generator that we've got here. So when it's in slow-mo, you can see it a little better. Straight wave. I don't know what that says, but that's the wavelength that they're showing with the arrows. And as they move. Now, I'm not going to show this one. I'm going to go back to this one here, circular waves, just to demonstrate, without sound. This is just for the benefit. Well, you guys, it shows up better than it does on it too. Just like me, I was pressing at a point, right? They just come out as a circle. Okay, that's a circular wave. I'm not going to show you the other. Then, straight waves, straight barrier reflection, something we saw already. This shows a little better. Hopefully. Okay. Yeah. That's one. That's what I was trying to draw. You guys see how it's kind of like an L kind of shape as it bends, and it kind of moves left to right on this diagram or on this video, right? That's what we were trying to watch, but we're watching many of it. Okay. Angle of reflection is equal to the angle of incidence. Then, last, circular waves hitting a straight barrier, what we just kind of saw too. Actually, that one we didn't see too bad. Just to reinforce this. Okay, boom. It's hard to see. That one doesn't, oh, there it's showing the reflection. I knew it was how it reflects right back at it. That's what we were trying to draw in our diagram, right? Okay, I'm going to pause the recording. Okay, I've just handed this out, and there's some terms. Yes. Okay, we need to get some words down and stuff, and I'm going to get you a copy of them out. So, term pulse. Now the arrow on this is just so I can drag it. What is a pulse? It's the crest or a trough of a wave. It's half of a wave like this. One push. And then a transverse. We're going to play around the strings and see. Pulse, where the amplitude is 90 degrees perpendicular to the direction of motion. That's called a transverse. So that's what we're going to be playing around with, the slinkies and whipping our hands like we whip a towel to generate noise. Are you copying this down, dude? You're going to just go home and watch the video. They will be. Yes, actually, yeah. No, I absolutely. I need. Okay, and then the word longitude. Well, wait. So, other kind of pulse that we're talking about is a longitudinal pulse. The amplitude is in the direction of motion. There's a couple of words. Now, if you can imagine, you know, on a pinball machine when you pull back that spring and stuff like that, that's the compression. Then it stretches out. Well, if you imagine you have compression, then the spaced part out is the rarefaction. Oh, I misspelled it there. I put rarefaction. Yes. Rarefaction. Now, okay. get out of your way.
Me off.